Hi, everybody. All right. This is our last shortcut on proving triangles congruent. So just to recap, we have four right now. We have side, 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 angle, angle, and angle, angle, side. Now today we're going to learn HL. And now HL is specific just to right triangles because the H stands for hypotenuse, and then the L stands for a leg of your right triangle. And just something to remember, hypotenuses only occur in right triangles. So that's why it's specific only to right triangles. So now again, any five of these shortcuts are fair game. So let's just kind of break this down a bit. So HL, hypotenuse leg, is if the hypotenuse and leg of one right triangle is congruent to the hypotenuse and the leg of another right triangle, then those triangles are congruent. So let's look at these triangles here. So remember, what makes a right triangle would be that right angle. And remember, your hypotenuse is always across from your right angle. So here's your hypotenuse. And again here is your hypotenuse. Right. So if your hypotenuses are congruent, which in our case, they're indicated, right? With these tick marks. So if BC is congruent to EF, and then either one of your legs. So again, a leg is just the other missing side or one of your other sides to your right triangle. So it could be either side, it doesn't matter, as long as one pair of them are congruent. So AB is congruent to ED, then those triangles are congruent. So when you saw this situation before today, if we were to go around, you'd be like, oh, that's an angle marking, a side marking, and a side marking. And you'd be like, oh, I know that doesn't work, right? Because it's SSA. We know that this is not a school appropriate word if we read it this way, right? So now when this situation happens like this, right? Check to see if it's a right angle, because then you could potentially have hypotenuse leg, which is what we have here. So it gets a little trickier now. We'll go through it slow and hopefully you kind of pick up on it. But if you see if you ever see a right angle marking, check to see if HL works, okay? So these next few examples, we're just deciding if the triangles are congruent. If so, which of our shortcuts is Y? I don't know why these are so small and blurry. So in this one here, we know that's a side marking, an angle marking, and a side marking. Same thing here. So these triangles would be congruent by side, angle, side. On this example, next to it, again, if we mark our label or our markings here, angle marking, side, just to make sure they're both the same. They are. So this shortcut here would be angle, angle, side. If you want to challenge yourself, please pause the video and try the next three examples on your own if that's something you'd like to do. If not, I'm just going to keep on keeping on here. We look here, angle marking, side marking, angle, just to make sure we're the same here, angle, side, angle. So indeed, these triangles are congruent. All right, this one here, we have an angle marking, side, side, angle, side, side. So this is one of those weird situations, right? If we go this way, side, side, angle, we know that this is not an option, right? Because that's not a school appropriate word. So when that happens, check to see if we have a right triangle. Oh, right angle. Oh, a right angle. So then it opens another door, right? It opens the door of, there's a hypotenuse congruence, and here's a leg congruence. So these are congruent by HL. You guys see that? So first thought, we're like, oh, it doesn't work because it's side, side, angle. But since we do have those right angles, HL is a possibility, so it worked. And then this last one here, angle, angle, angle. Well, we know that angle is not a thing, so they're not congruent. Okay, super. Next, on to a proof. So, I'm going to just move these up because I can. Here we go. We're going to have statements and reasons. Now just remember, anything's kind of fair game with these proofs on which shortcut we're using. So our goal is to show that these two triangles are congruent. We're given that AD is congruent to BC, Y, given, and it's already marked for us, but I'm just going to kind of darken it. And then we know that angle A and angle C are right angles, given. Okay, so we've gone through the givens. And remember, your givens are telling you something, right? It's not just like for funsies. I mean, they're there for a reason. They're either wanting you to make a leap from one piece of information to the next piece of information, or it's just free information, right? So AD being congruent to BC, that's free information. We can't do anything else with that. So that one's done. But angle A and angle C being right angles is telling us something. And that's telling us that we would have right triangles, right? So then I would know that triangle ADB and triangle BDC are right triangles by definition of a right triangle, right? Because if there's a right angle, it makes it a right triangle. Okay, so now I have two right triangles, which is good. All right, I gotta clean this up a bit. So I have two right triangles, which is awesome. So now, if we have a right triangle, look to see if HL is an option, right? Because that's kind of like a little shortcut. So I'm looking here. I already have a pair of legs that are congruent, and then conveniently enough, you guys look, DB is the hypotenuse in both of those triangles. So now we can say DB is congruent to DB by, not definition, reflexive, right? The reflexive property. The reflexive property. So now, folks, let's look. Now it's kind of hard with my screen just not cooperating. There we go. Do we have enough information? I think we do. Because if we go around like we would before today, you would say side, side, angle. We know that's not an option, right? So then it's like, well, we said that these are right triangles, which is super helpful. Because now we've shown our hypotenuses are the same and our legs are the same. So our triangles are congruent by HL. Triangle ABD is congruent by triangle CDB. And that is by HL. So now, just like a heads up in future proofs or whatever it may be, if you're going to use HL as your reason of proving your triangle's congruent, at some point you need to say that they're right triangles. You need to say at some point their hypotenuses are congruent, and at some point you need to say a pair of legs. So those are the three pieces, 1, 2, 3, that you need to have in order to use HL. Okay? So again, like the weird one that comes from HL is that you have to say that they're right triangles. Otherwise, it doesn't work because HL doesn't work in any other kind of triangle since hypotenuses only occur in a right triangle. All right, folks. This last one, it's a bit of a doozy, I'll be honest. We're going to change it just a tish. Instead of proving that those lines are parallel, will you guys change this so it says BC is congruent to AD? So we haven't really seen a proof like this before, which is okay. We will be seeing more of these next week when we do like our proofs review before our test. So it's a good segue for us. So again, we're going to start like we normally do, statements and reasons. So our end goal is to show you guys that BC here is congruent to AD. So that's our end goal. In order to reach that goal, we have to first show that these two triangles are congruent. Okay, so first we have to show that triangles are congruent, and then we can say that last step. So maybe it's better right now for you to think of, how do I show these triangles congruent? So let's just start with our givens and see where that takes us, all right? So start with given number 1, angle A and angle C are right angles. That's a given. And then we know that AB is parallel to DC. Okay, so now let's just look at our picture. Okay, so let's try to show these two triangles are congruent. So we have a pair of angles congruent, right? Angle and an angle. And then we're told that these two sides are parallel. Now, folks, remember, if they're giving you ever giving you parallel lines, at some point you need to use congruent angles. They're giving you congruent angles somewhere. And honestly, guys, almost always it's going to be alternate interior angles. So if we look here, if this line's parallel to this line here, I have a pair of alternate interior angles right here and right here that are congruent. So I think that's what we should say next. So angle, trace them out, ABD is congruent to angle CDB by alternate interior angles. Excuse me, you guys, I'm sorry. Okay. And then now, so right now, I have this angle and this angle. Yikes. Now we need to show, we haven't said the angle A and C are congruent yet, so let's say that angle A is congruent to angle C. Why are these two angles congruent? Well, they're both right angles. So all right angles are congruent. Jeez. Having a coughing attack over here. All right. So now we're just missing one piece to show these triangles are congruent. And if you look in the middle, they both share BD. So BD is congruent to BD. And that's our favorite reflexive property. Okay, so really a little hairy with this part. We haven't seen that before, but up to this point, you should be okay because we've proven triangles congruent. So if we look here, the reason why these triangles are congruent is angle, angle, side. So let's say that. So we can say triangle ABD. Now match it. What matches A? C. What matches B is D, and D matches B by angle, angle, side. So now that we've said our triangles are congruent, we know matching parts are congruent. So now we can finally say this last part, you guys. BC is congruent to AD. Now look, if I look here, AD, first and last letter of this triangle. BC, first and last letter of this triangle. Do you guys see how they're in matching spots? And look at our picture if that doesn't make sense. BC, AD, are they matching corresponding parts? Yes, so I know they're the same. And I know I said this, and I don't even think half of you watched this first video, so you're like, what is she talking about? But we wrote down this thing called CPCTC, and it stands for corresponding parts of congruent triangles are congruent. So it's just a shortcut way of saying they're in matching places, and since I've proven the triangle's congruent, Therefore, they're congruent. So C, P, C, T, C. All right. So I know that was kind of a pretty involved proof for me to not be with you today. I don't believe there's one like that on your worksheet today. I think it's more like the proof we just did before, where you have to say the triangles are right triangles, and then you're using HL to prove them. But it's just good for us to see them. It's good for us to work our brain a little bit differently than we've been doing. So don't get bent out of shape. Try your best. Please be good for the sub. Help each other out, but don't be too crazy. And I will see you next week. Okay, goodbye.